Okay, so the second part of section 4.6, completing the square, we're going to look at some examples when a does not equal 1. So the most important part here to know is that if a does not equal 1, you have to change it so that it does equal 1. Okay, so a always needs to be equal to 1. Otherwise, completing the square will not work. So the first thing to do is to move everything over to one side. Again, I like to check and see if maybe I'm already given a perfect square trinomial by looking at these two terms. They're not perfect squares, so right off the bat, I know that's not a perfect square trinomial. So I'm going to go ahead, I got to get that a value to 1. So divide everything by 5. That way, it goes to x squared minus 6/5 x minus 8/5. Now, you probably want to put those into decimals, but do not convert to decimals. It actually makes it harder. So we're going to go ahead and complete the square by moving that constant to the other side. I like to fill in my little blanks here to remind me that I need to find the term that will allow me to complete the square. So this is where your b over 2 squared value comes into play. So negative 6/5 divided by 2. Use a calculator. That's negative 3/5. And then square it, which gives you 9 over 25. So we're going to add that to both sides. Remember, it must be both sides to keep the equation balanced. You're not changing the equation, you're just changing the way it looks. Now, even though this might not look like a perfect square trinomial, because we did completing the square, it automatically is. So therefore, we can go ahead and we can factor it. So square root of x squared is x. Square root of 9 over the square root of 25 is 3/5. And then both are minus signs. And we know we can write that as one single set of parentheses raised to the second power. Now, take your calculator, type this part in. And again, if it gives you a decimal, make sure you hit math, enter, enter. So when you do that, you should get 49 over 25. And now we just solve. So take the square root of both sides. When you take the square root of 49 over 25, you get plus or minus 7/5. Continue to solve here. So x equals 3/5 plus or minus 7/5. You do want to take that and break it out as two separate answers since you can easily simplify that. There's no square roots involved. So that'd be what, 3/5 plus 7/5, which is 10/5, which is 2. Or the other answer is when you use the minus sign. So 3/5 minus 7/5 is negative 4/5. Okay. So the only extra step that is involved is making your a value 1 by dividing everything by whatever the coefficient on x squared currently is. Otherwise, all the steps are exactly the same as what we did before. Okay, so let's go ahead and try letter B. Maybe pause this video, try it on your own, and then unpause it and see how you did. But otherwise, I'll just talk through this again. So first thing, I'm going to go ahead and move that 6 to the other side. check and see if I'm given a perfect square trinomial. No, 2 is not a perfect square, so I can just stop there. So I need to go ahead and get rid of that coefficient of a 2 there, so just divide everything by 2. So we get x squared plus 1/2 x minus 3 equals 0. I'm going to go ahead and complete the square by moving that -3 to the other side. And then my goal is to find whatever that new term is that I have to add to both sides. So this is where your formula comes in play. B over 2 squared. So that's 1/2 divided by 2, which is 1/4. And when you square that, you get 1/16. So that's what you need to add to both sides. Now this is a perfect square trinomial. That's the whole point of doing this complete the square process. So in my parentheses, you're welcome to keep writing it as 2 of them if you want, and then going down to the single one. But I'm just going to go ahead and start writing it like this. So that's going to be x. And then again, you think of the square root of 1 and the square root of 16, which is 1/4. It's going to be a plus sign. Equals, take your calculator, put this into the calculator, and hit math, enter, enter. When you do that, you get 49 over 16. So now we take the square root of both sides to get x plus 1/4 equals plus minus 7 over 4. Subtract 1/4 to the other side. Break out your 2 answers. All right, the last one here. Again, I would pause this video and try this one on your own, and then you can go ahead and watch. Make sure you did it correctly. But last one, I'm going to go ahead and get everything over to the left. Not a perfect square trinomial, pretty easy to tell right off the bat because of this term. So therefore, I need to complete the square. So let me go ahead and divide everything by 2, since my leading coefficient is not a 1. You might be tempted to use decimals, but do not use decimals. It will make your life harder. Let's move that positive 2 to the other side by subtracting it to become a -2. Find your new term that you need to add to both sides. So -3/2 divided by 2 would be -3/4. And then when you square that, you get 9/16. So you got to add that to both sides. So now we have a perfect square trinomial here. So my parenthesis is going to be x. Square root of 9 is 3. Square root of 16 is 4. Whoops, not plus, should be a minus. It's going to be a minus sign because of this sign here. Take your calculator. -2 plus 9/16 is -23 over 16. And then take the square root. So x minus 3/4 equals plus minus the square root of negative 23 over 4, right? Because the square root of 16 is 4. You're going to go ahead and add 3/4 to both sides. And then at this point, you do not need to break out your two answers because we have a square root. Okay, so we are just done. That is our final answer. We can stop there. Remember, guys, you have not learned yet about the negatives inside the square roots. We're going to do that in section 4.8. So you can just leave that as negative 23 inside that square root. Okay, but that's it. That's the rest of the notes for section 4.6.